Hi, everybody. Let's learn a little something today about symmetry. There's two main kinds of symmetry that we're going to look at, rotational symmetry and reflectional symmetry. The first picture here is an example of rotational symmetry because I can take this picture and I can rotate it. Now keep in mind, not one of our usual 90-degree rotations, but if I go a little bit more, do you see how that image looks exactly the same as the initial image that I started with? So there's the image that I started with, and then I can rotate it 90 and a little bit more, and it looks exactly the same. And then I can actually do that one more time too. There we go. Before I rotate it, before I rotate it back to the image that I started with. So you can, if you rotate something a full revolution, that's 360 degrees. Well, this one, there's 3 different rotations that you can do before the image gets back to where it started with. So if you want to know the number of degrees of rotational symmetry, we can go 360 degrees divided by 3. It's 120. So the first rotation that we did was 120 degrees. Then we did 120 more, so 240 degrees. Then we did 120 more, but that got us back to 360 degrees. I never list that for rotational symmetry because, of course, when you rotate something by 360 degrees, you get back the image that you started. All right, the second picture is an example of reflectional symmetry. So we're not going to rotate this image. We're going to reflect half of an image over a line. So if I draw this line of symmetry right here, if I folded the right half of the heart over that line, it would lie perfectly on top of the left line of the heart. So it has reflectional symmetry. I believe this one just has one line of symmetry, that vertical line. If we scroll down, the hexagon is an example of both because I can rotate 1, 2, 3, 4, 5, 6 times before I get back to where I started. So the rotational symmetry is 360 degrees divided by 6. It has 60-degree rotational symmetry. So we can rotate it 60 degrees, another 60, which makes 120, another 60, which makes 180. That just flips the hexagon upside down. Another 60, which makes 240, and another 60, which makes 300. So that's the rotational symmetry that we can do. Then for reflectional symmetry, how many lines of symmetry can we draw on this one? This time this one has a bunch because we can draw these lines of symmetry from vertex to vertex that cut the hexagon in half. So there's 1, 2, 3 of those. But we can also draw these lines of symmetry that cut the hexagon in half. So there's also 1, 2, 3 of those. So there's actually 6 lines of reflectional symmetry, which is a lot. Six lines of symmetry. All right, let's look at that final image, that lightning bolt. Can we spin that lightning bolt around and have it look exactly the same as the original image? At first, I was thinking, well, maybe you could flip it upside down, but no, that doesn't look exactly the same as this image. So there's no way that I can flip this lightning bolt. There's no way that I can rotate it around where it's going to look the same as the original image. Are there any lines of symmetry I can draw that cut the lightning bolt perfectly in half where the two halves are mirror images of each other? And the answer to that is no as well. So this one has no rotational symmetry, no lines of symmetry. All right, so the final thing that I want to do on this note sheet is to try to define rotational and reflectional symmetry. I feel like that's not that easy to do, but if we think about what we did, we can kind of try to put that into our own words. So rotational symmetry, we took an object and we rotated it in some certain way by a partial turn, less than 360. And it looked exactly the same as the image that we started with. So I'm going to say rotate an image by a partial rotation. And by that I mean, in parentheses, less than 360. And the resulting image will be exactly the same as the original. There's probably another way that we could have phrased that too, but that was the best that I could come up with. Okay, so what is reflectional symmetry? So sometimes this is also called line symmetry because if you draw a line of symmetry in the object, half of the object is a perfect mirror image of the other half. So when you draw a line of symmetry, half of the object is a mirror image of the other half. If you come up with a better definition for either of those, let me know because I'm open to some editing, but that gives you a little bit of a basic idea about rotational and reflectional symmetry. Let me know if you have any questions. Bye.